Wait, what is this on?
What is this on?
Like, what is this worksheet about?
This worksheet's about the excitation of electrons. So exciting electrons and seeing different colors appear from the excitation of those electrons. So we're moving the electrons to different energy levels, and we're seeing what happens when they move to and come back to their normal energy level.
Okay.
So I do want to go over, starting at 14, I want to go over number 14 with you guys. So number 14 set on 14 through 18 with you. So number 14 said electrons and protons attract or repel towards each other. So do electrons and protons, do we think they attract to one another or repel from one another?
Attract.
Attract, I like it. They're going to attract because we have that positive protons and negative electrons. So the two of them are going to attract towards each other because they're at opposite charges. And then it says for number 15, as an electron gets closer to the nucleus, the attraction or repulsion to the nucleus gets stronger or weaker. What do we think here?
Attraction.
The attraction to the nucleus, is that going to get larger or smaller? Bigger, stronger, weaker?
Oh, stronger.
Perfect. It's going to get stronger as we get closer. The closer we are to that proton, that positive charge, the stronger the attraction is going to be. So those electrons, when they get closer, are going to be pulled in closer to the nucleus. Question 16 says, for an electron to move from an energy level close to the nucleus to an energy level far from the nucleus, it would need to gain or lose energy. So for this one, let's go through another idea. Does anybody have a favorite like candy or a favorite snack or a favorite food or drink? Skittles, all right. Diani has a favorite Skittles. Her favorite snack is Skittles. So she has a bag of Skittles. It's like one of those king-size bags. It's a giant one. She's got a bag of Skittles in her hand, and she's hugging onto those Skittles. I come over, and I want to steal her Skittles. Am I going to be able to steal those Skittles without putting a lot of effort in?
Yeah, no.
No, I'm not going to be able to steal those Skittles. It's going to be super hard for me to take those Skittles away from her. Even if I pull them away from her a little bit, they're going to be pulled right back in. Well, it's the same thing with our electrons and our protons. Those protons are Diani. They're holding on to those electrons, which were the Skittles. They're holding on to those Skittles as tight as possible. They're holding on to those electrons as tight as possible. So we're going to have to put in a lot of energy or a lot of force to take those electrons and pull them away. So we're going to have to put in or gain a lot of energy for the electron to move away from the nucleus. So to get to a higher energy level. So if we're going to have to put in or gain a lot of energy for that to happen, question 17 says the electrons move from an energy level far from the nucleus to an energy level close to the nucleus. Would they gain or lose energy here? So if they're moving back closer, what's going to happen?
Move energy.
They're going to lose that energy because they're moving back towards the nucleus. So that energy is just going to go off somewhere else. It's going to leave the electron. It's going to leave that atom. It's going to go do whatever it wants. So now that we know that, we have to read a little bit so we can understand the key terms that we're going to be talking about when I'm talking about gaining and losing energy. So it says that Niels Bohr modified Rutherford's nuclear atom model to explain how light interacted with the electrons in an atom to produce spectral lines. His model included electrons orbiting the nucleus at specific energy levels. Electrons absorb energy from various sources, like electricity, when they move from lower energy levels, called the ground state, to a higher energy level, called the excited state. Energy is released as electrons return to the lower energy levels. So before we get started, I want to ask the question, do we think that this one is going to be, oops, wrong way. Do we think that this one is going to be the excited state or the ground state? At n equals
The ground state.
All right, I heard the ground state, which is correct because it's that lower energy level. It's at 2, which is the lower of the levels. So this is going to be our ground state. And then this one here at 5 equals 5, is that going to be our, what stage is that going to be then? This is the ground. The top is going to be the kind of state?
Excited state.
The excited state. Perfect. So we're going from our ground to our excited state because it's moving from n equals 2 to n equals 5. So is the energy absorbed or released for these electrons to move from n equals 2 to n equals 5?
It's being observed.
It's being absorbed. Perfect. Because it told us up above that electrons absorb energy from various sources when they move from the lower energy levels to the higher energy levels. So we are absorbing energy to move from the ground state to the excited state. All right. Are there any questions so far? I'm going to take our silence as a no. I don't have any questions, and I can keep going. All right, so then question 19 says identify the drawing in model 3 that depicts a hydrogen atom with the electrons moving from n equals 5 to n equals 2. So energy level 5 to energy level 2. So which one of these spots is our electron going from n equals 5, the 5th ring, to n equals 2, the 2nd ring or the 2nd orbital?
E.
B, perfect. So we're going to label that n equals 5 to n equals 2. And just for fun, let's go through the other ones and identify those two. So A, what are we starting at? N equals what? What would be our outermost? What we're starting at?
4.
What number?
5.
4.
For this one, A. Where's that ring starting? So if we start
4.
here, right? Not 4. So if we start here, if I just trace it back, if I go to the numbers, I'm at
6.
6.
6. There we go. So n equals 6, 2. And where do we end? If we end right here, where are we going to end?
2.
2.
2.
Perfect. N equals 2. What about C? Where are we going to start for C?
4.
There we go. N equals 4. And we're going to end at
2.
n equals 2. And then D, where are we starting?
3.
3. And where do we end?
2.
N equals 2. Perfect. All right. So now we have those. It also says that we need to identify the corresponding light that's being emitted. So these are all hydrogen atoms. So these are all our hydrogen atoms, which means that we need to look at our spectral line for hydrogen. And so hydrogen has these 4 different lines, or these 4 different colors that are going to be emitted. So that we have violet, blue green, and we have red. And they give us wavelengths that go along with them. So we have the wavelength for violet is 410, the wavelength for blue violet is 343, and all the way up to red, which is 656. So if we looked at this one, okay, which one of these do we think is going to be violet? The one with the shortest wavelength?
A.
A, perfect. If we look, the wavelength is really how long it takes to complete one wave. And so this one, it is our smallest little humps or smallest little waves right here. So this one's we're going to label as violet for A because it's our shortest wavelength. Which one has our longest wavelength? Which one would we label as red?
E.
B, perfect. This one's going to be our red because it has the longest wavelength, the longest time to complete one wave. All right, we have blue violet, which is our next shortest wavelength. Which one is that one going to be? B.
B.
All right, blue violet. And then blue green is then obviously what letter?
C.
There we go, C. Blue green. And these came from those spectral lines up above. Those 4 colors is where we came up with them. And then it says for B, is the electron transition absorbing or releasing energy? Are we absorbing or releasing energy here?
Releasing.
We're releasing energy. That's what those lines are for. We're releasing energy right here. Perfect. So then it says for C, this electron moves from a lower or higher energy state to a lower or higher energy state. So are we moving from a low energy state to a high energy state, or a high energy state to a low energy state?
Lower to higher.
Moving from lower to higher? Does everybody agree?
Yeah.
Yeah? All right, I'm going to disagree then, because energy state or energy level or number, which one do we start at? Do we start at the higher number or the lower number?
Oh, the higher number.
We're starting at the higher number, so we're starting at a higher energy state, and we're going to that lower number, which is going to be the lower energy state. So we're starting, for these pictures, we're starting at that excited state, the higher energy state, and we're going to that ground state, the lower energy state. The last one, is light being absorbed or is light being released in the electron transition? So are we absorbing or releasing our light here?
The light is the squiggly line, right?
The light is the squiggly line, perfect.
They're releasing.
We're releasing it. Our light is our form of energy that we're releasing. The light is just the specific type of energy that's being released here. So our light is being released. Any questions so far on anything we've talked about today?
No.
All right. So then question 20, we actually already did all of it except for the last section, which says use your colored pencils to trace the lines. So all it wants you to do is take your pen or pencil and go back and trace in these lines with the correct color. So you're just tracing in, like this one is violet. So then you're just tracing in each of the colors on this with the correct color of light that's being released. So violet, blue green, or red. And then there are 6 more questions, 3 on this page and 3 on the next page for you guys to complete on your own. So you guys have time to work on your own to complete the rest of this worksheet. There's also a light ed puzzle that I want you guys to attempt. I believe it is like 7 minutes long, and it has like 6 to 8 questions that go along with it that just help reinforce this idea of light being released from when we excite electrons. So when we add heat or when we add electricity to these atoms, we're going to excite those electrons, and when they fall back down, we see a color come out, and those colors are specific to each of the different elements. Just like I told us before about the fingerprints, and each element has a specific color pattern. Each fingerprint is different for each person. So are there any questions on what you guys need to be doing the rest of the day?
No.
All right, then if you have no other questions, you guys are good to go. If you have questions, you want to